Pythagorean theorem you guys are probably familiar with. A squared plus b squared equals c squared. What kind of triangles are the only triangles we can use the Pythagorean theorem with, Nate? Only right triangles, okay? That's it, right triangles only. So make sure you have a right triangle like this one, where we have this little angle right here. That means it's a right triangle, okay? Now, when we're doing the Pythagorean theorem, it is very important that you know which leg is which, all right? So this right here, the one that is opposite the right angle, this guy is called the hypotenuse. Good. Okay, hypotenuse. So that has to be this side right here. All right, hypotenuse is C. A and B are interchangeable, you guys, but whoops, they have to be the legs. I call them the legs versus the hypotenuse. So the legs meet at a right angle, and the hypotenuse is always opposite of the right angle. Then we can do a squared plus b squared equals c squared. This helps us find the lengths of the sides. All right? Use the Pythagorean theorem to find the unknown lengths. So I have 5 and 6 and p. Okay? So Evan, which side's the hypotenuse? The p side. Good. So for our formula, we have a squared plus b squared equals c squared. So a and b have to be the legs. So I'm going to plug 5 and 6 in for a and b. It doesn't matter which is which, but they have to be on this side of the equation. So I'm going to plug 5 in for a, 6 in for b, and then p in for c. And we have to square all of them. Okay? So 5 squared is 25, and 6 squared is 36. Then we can add those together, and what do we get? Good. Okay. Final answer is to take the square root. Now, yesterday you guys learned that the answer would be plus and minus when you're solving an algebraic problem. But when you're doing geometry problems, can I have a negative length or distance? No, I don't know how to measure negative distances, right? So your answer is always positive when we're solving for a length. So square root of 61. Okay, what if my triangle looks like this? Micaiah? Do a decimal answer?
Yeah.
No, you can leave it like that. Okay. All right. So I've got T, 5, and 15. So, Riley, which side is the hypotenuse? Yes. So this side right here is the hypotenuse. The other two are the legs. Isaac, do you have a question? Yep.
The longest side or no?
Yes, the hypotenuse is also the longest side. Good call. All right, so a squared plus b squared equals c squared. So a and b are the legs, which means the two sides that meet at the right angle. So I'm going to plug t in for a and 5 in for b, and my hypotenuse in for c. So t squared plus 25. Anybody have 15 squared memorized? Corey? 225, nice. All right, now we have to, on this one, we have an extra step. We got to subtract the 25 here from both sides to isolate our variable. So t squared equals 200, and we're going to square root both sides. So t is equal to. Now, if you have one that is to be simplified, like this one, okay, I would go ahead and do that. 200 is the same thing as 2 times 100, and what's the square root of 100? 10. Okay, so 10 is going to come out front, and the 2 stays inside. So 10 root 2, okay? All right, Pythagorean triples. These come in really handy if you memorize some of these. Not all of these are triples, all right? So Pythagorean triples are groups of 3 integers that satisfy the Pythagorean theorem. Anybody know one of these off the top of their head that is definitely a triple because you memorized it, Drew? Yes, the 3, 4, 5. You guys will see this on the ACT and SAT all the time. and it will save you time because you won't have to do Pythagorean theorem. If you see the sides 3 and 4, automatically you know the hypotenuse is 5. Okay? Yeah, Isaac. What's another one? 9, 12, 15. How do you know that is another triple? It actually compares with this one. Anybody see? Bethany? Yep, you can also use multiples of the triples. So if you times this by the exact same number, right, then you get 9, 12, 15. That's always going to be a triple as well. All right, Jackie? 5, 12, 13. Okay, that's not a multiple of this one, but she has this one memorized. We could check it, right? The longest side has to be the hypotenuse. What's 5 squared? 25. What's 12 squared? When you add those, what do you get? What's 13 squared? All right, so that one works. Okay, 5, 12, 13 I have seen on ACT problems. So it is nice if you can skip that whole Pythagorean theorem and have it memorized. Monica? 6, 8, 10 is another one. How do you know? Good. You can multiply 3, 4, 5 by 2 and get 6, 8, 10. So that's also one you could memorize or know it's a double of the 3, 4, 5. Okay? This one's definitely not. I don't know if you guys want to check it or not. This one's definitely not. How about 8, 15, 17? Should we check that one and see if it is? Yeah, let's check it. All right, so we've got 8 squared plus 15 squared equals 17 squared. Again, to check, be sure you put the biggest number in the c squared spot, because that's the hypotenuse. What's 8 squared? Good. What's 15 squared? 225. Anybody got 17 squared memorized? Caleb? Nice. 289. All right, if we add these, guess what we get? 289. So is that a triple? Yes. Boom. Look at all those triples. All right, how about 7, 24, 25? Should we check that one? All right, 7 squared plus 24 squared equals 25 squared. 7 squared, anybody know it? Yeah, we know that one. All right, 24 squared, anybody know that one? I don't know that one, I don't think. Anyone know that one? Someone do that. Corey? 576, okay. I do know 25 squared. Anyone know that one? Nice, 625. Okay, how about 576 plus 49? What do you guys think that is?
625.
Yep. Good. So this one is also a triple. 7, 24, 25. Okay? So I would write down all the ones that actually work, which is most of those that we put up there. All right? If it doesn't work, we didn't really check to explain that, you guys, but let's say I tried this one. 4 squared plus 5 squared equals 6 squared. What's 4 squared? What's 5 squared? What's 6 squared? Okay, add those together. What do we get? 41. Does that equal 36? No. Okay, so if you get two things not equal, then it's not a triple, and those sides will not make a right triangle. Okay. All right, use the triples. When you know the triples, your life is just so good. All right, it's so good in math. So, anybody know what W is based on the Pythagorean triples? Jordan. Very good. Boom. W's 5. Didn't have to do the Pythagorean theorem. All right. And this one, we've got 27 and 45. So this might be a multiple of 1. If we could find a multiple that would work. Okay, let's see. Josh, what do you think?
36.
This would be 36. How'd you figure that out?
27 times 9 is, 3 times 9 is 27,
Yep.
so 4 times 9 equals 36.
And this one is 5 times 9. So this is the 3, 4, 5 triangle, all multiplied by 9, okay? Always try the 3, 4, 5. It comes up a lot, all right? 36. Nice, Josh. All right. And let's see if we can get this one. We've got 15 and 39. Think about what those numbers are divisible by. That's kind of how I go, and then work your way back. Evie? Evie? What do you think? Evie? Sorry, I get confused because sorry. 36, how'd you do it? All times by 3, so G is 36. Nice. That's really good. All right. try it on the whiteboards.